Got it. Hello.
Go ahead.
Hello. Hi. Hello, Laracon. My name is Evan You. I'm the author of Vue.js, and So today I'm just going to be going over a bunch of stuff about Vue.js in this talk, workshop. It's not going to be a real workshop in that like we're going to be doing a lot of code or something. We are going to be talking a lot about the higher level ideas behind Vue.js and all that. So before diving in, can I see a show of hands, like how many of you have like at least used Vue.js in some context? Wow.
You're awesome.
Woohoo! Thanks, guys. Okay, so I assume a decent amount of you already kind of have basic concepts of how Vue.js works, but maybe you've only went through the Laracon tutorial, but you never spent the time to actually read the guide. So this talk is going to be going over some of the things you might have missed. All right, so it's also going to, I tried to make it approachable for people who've never even used it before. But before we actually diving in, some brief background. Vue.js was first created as a very experimental project back in 2013, late 2013. That was when I was still working at Google. And I used it in a bunch of prototypes that I worked on at that time, and I felt this idea is legit, and I published as an actual project called Vue.js in February 2014. That was almost, actually more than 2 years ago. So yeah, it's been quite a long time, actually. So for quite a long time after release, it was kind of like still in a very side project, personal project state, where I basically threw it out there and didn't care much about how it grew. But in April 2015, this happened. So Taylor was looking for something new on the front end, and he tried React, and he was like, I'm overwhelmed, right? I'm just gonna learn Vue.js instead because it looks easy and has a pretty website. I guess it was partly because the website has a very similar style to the Laravel site, right? So after this tweet, this was the Google Trend stats. So yeah, this is amazing, right? And today, Vue.js has 23,000 stars on GitHub, has 150K downloads per month on NPM only. That's not including CDNs and direct downloads. And $8,000 a month support from the community. This is amazing. So a big shout out to all the sponsors and backers that's making my full-time development of Vue.js possible. And in particular, big thanks to the Laravel community for making this possible. Thank you, guys. All right, so now we're getting into the real stuff. So the core concepts of Vue.js are two things. First is declarative and reactive rendering. And the second is component-oriented front-end architecture. So I want to, this is mentioned in the beginning of the guide, but it might seem a bit abstract if you've never used Vue.js before. So we're gonna go from some really basic concepts. Declarative and reactive rendering, and why do we need it? So the quintessential problem of any front-end development, if you boil it down to the very, very essential things, is how to keep the DOM and the state in sync. So the DOM actually has a very light gray background. But how do we, you have some data, right? You grab the data either from the server or you have, if you're doing a very traditional backend application, for example, if you render everything on the server side with Laravel, you're already having a template layer on the server You have the models, you have everything on the server, and in the end, you're just spitting out static HTML to the client. But that model quickly, but there are also other things on the front end that you need to do. For example, what if the user toggles a dropdown, or what if the user is validating some forms? Like there are a lot of tasks that you want to do on the front end without actually reloading the page. So the server is not even involved in those tasks. So how do you manage those complexity? So essentially what we're getting at is we have some extra state on the client that is not related or managed by the server. These are called client-side state. And we have, as front-end, when you're doing front-end work, it is your job to keep these client-side state in sync with the actual DOM. So in the past, a typical approach is we use the DOM as the actual client-side state itself. Because the DOM is stateful by itself, right? So we think, hey, we can just manipulate the DOM directly. That's what jQuery is for. So the philosophy of jQuery is you find something and you do something with it, right? If you think about this statement, this is very imperative. You find something, you get a reference to it, then you do something to it, you mutate it. So the problem with this is that how many of you have written jQuery spaghetti before? Right? So I think we all kind of understand what would result in if you just do everything imperatively with a DOM. It just quickly becomes a terrible mess that's unmaintainable. So how do we tame this craziness? How do we make it easier, make it more declarative, so that your state is always automatically in sync with the DOM? And better yet, if we can just get away with the DOM, because the native APIs are terrible, right? That's why we use jQuery in the first place. But it's even better if you can do without jQuery, so that we make everything declarative. So I talked briefly about the problems with the DOM just now, right? So imperative manipulation is bad. So what about just re-render everything every time? Right, like we do on the server, because every request comes in, you're rendering a new view and returning to the client. So that is actually declarative, right? Because you are doing everything in one pass, and you're not changing it later. That might be great, but on the client, this is not feasible, because throwing away some already rendered DOM and replace it with new ones is very expensive. It's inefficient on the client. If you have a full page and you replace the whole DOM with new DOM nodes, it's going to take a lot of time, and your user experience will be deteriorated. And it's also disruptive, because when you replace the DOM nodes, there are transient states in the DOM that might get thrown away. For example, the cursor positions, the highlights, or temporary input state, right? These are all going to be thrown away if you replace the DOM entirely. So the better way to do it is, do surgical, precise updates, only directly proportional to what is actually changed in your state, right? So previously, what we've actually been doing with jQuery is trying to manually perform these surgical operations by ourselves. So that's why it's so hard, right? So we want an intelligent system that helps us do this automatically. And that's where Vue.js comes in, right? So we want this declarative and reactive rendering where the state is the single source of truth, and the view is just a declarative mapping of the state, right? So the view will be the DOM, right? So user will interact with your DOM. They will dispatch DOM events. And what we do in response to user input events, instead of directly changing the DOM again, we change the state instead. So because state is just simple, in-memory objects, which is much easier to reason about than the actual DOM, because you can model it the way you want it to, instead of having tons of nested LIs, divs, spans, Ps, and all that. You can model the state the way you want it to, so that it becomes easier to reason about it. So when you mutate the state, this is where the reactive part comes in. Vue.js makes your state reactive so that whenever you change something, it intelligently re-renders your DOM by applying the minimal amount of DOM manipulations. So it's fast, efficient, and it's declarative. So that's the kind of the premise of why Vue.js exists. This idea is, has been basically the common ground for any modern front-end frameworks. But Vue.js uniqueness is in that it makes your state reactive by default, so that you don't have to actually think about the re-rendering process when you are mutating your objects. So the most basic example, we have a piece of HTML, which is the template. As you can see, we use the double mustache tag, very familiar syntax to do interpolations. And what it does under the hood is the VM is a Vue instance. We create a new Vue instance, and the L option is the DOM mounting point. It tells us to mount the Vue instance onto this piece of DOM, and it will take the content of that piece of DOM as the template. It will compile it, and it will try to match the corresponding values inside your state. This is the data object is your state, and map it to the interpolations that you have specified in the template. And now, once this is done, whenever data.message changes, this will change accordingly. So a higher level view of this would be state is just plain JavaScript objects. The view is the DOM. And view is kind of like, this thing in between that keeps things in sync. So this is the diagram that I used to, put under the label MVVM. But I'm kind of moving away from that now because when you talk about design patterns, people often tend to become very, they try to talk about where it originated from and what's the strict definitions are and all that. But I think I don't really put Vue under any strict design paradigm or design patterns. So this has similarities with MVVM, but I would not call it, not call Vue a MVVM framework on a very strict sense. So Vue instance takes care of attaching event listeners to the DOM, and when that happens, you can mutate state inside those event listeners, and when the state changes, Vue detects them and applies updates back to the Vue. And in 1.0, Vue applies those updates via directives. These are like individual bindings in your templates. And in 2.0, we use a different mechanism called virtual DOM, which we will talk about later in this talk. So, quick demo time. Disclaimer, I didn't really prepare for the code. I want to write it just raw. So actually, we will be using Vue 2.0. So this is kind of like the first public live coding of Vue 2.0. Wish me luck. Laracon demo. Oops, I misspelled it. All right. I need to give it a extension. OK. So I'm just going to be using the local build here. And ID equals app. OK. Have a script. And we're going to do our new view. So exact the same interface with 1.0 if you're using the full standalone build. Our VM is just going to be. So I'm going to be, are most of you familiar with ES6 or you'd prefer ES5? 6? OK, great. That's the only difference. So what should we build? Let's build a to-do list, of course. What else can we build? All right. that. So we have an li, right? We have a bunch of things. So first, when you are building a Vue application, the first thing you want to do is think about your client-side state, right? So if we have a to-do list, what would it look like, right? So let's have a to-dos, which is going to be an array, right? So each to-do is going to be an object in the form of, it maybe has a text, right? Hello, Laracon. And it has a done property, and we're just going to set it to false. Well, it's true because I already greeted you guys. And then text, deliver the talk, done is false. All right, so we'll just have two to-dos in the list right now. So we need to make our templates describe how to display this state. And we're going to use the v-for directive, right? So this is similar to all the loop iterations. And in 2.0, the v-for syntax, the most basic syntax is almost exactly the same. You just do to-do in to-dos. And you can render something inside, so we're going to do to-do.text. So let's run this. Laracon demo. Whoops, it doesn't work. Because, we didn't give it the L. OK, so the L option tells us to actually mount the instance to this piece of DOM, right? But there's also another way to do it, which is you can create the instance first and then call the mount option. So we can do that. And now it should work. Let me make it big. Whoops. OK, so we have the list now. Now we also want to display whether it's done or not. So as you might know, we can do JavaScript expressions inside bindings. So not only can you do these property bindings, we can do expressions. So what you can do is to do done. We are using a JavaScript ternary expression here. If it's done, we say done. If it's OK, so let's wrap it in parens. OK, so now we know which talk is done and which talk is not. So the natural next step is we want to be able to check an item as done or not done. So let's add a button for each item. Is the text big enough? OK. Slightly bigger. OK, so button, should we make it toggle, I guess? Well, actually, you can maybe use a checkbox, but let's keep it simple and make it toggle. So the way you attach event listeners in your templates is using the v-on directive. So you might wonder, why are we attaching event listeners in templates, right? Isn't this bad? The thing is, because you're using Vue, this is actually better if you do it in the templates, because you don't want to manually try to. So there are three ways of handling this, right? You do it directly in the template. You attach the event listeners imperatively when you're inside your Vue model lifecycle hooks, or you can, similar to backbone views, where you specify a mapping of selectors to event listeners. So I think there are pros and cons for each, but using inline listeners, the benefits is that Vue can declaratively handle all the lifecycle of these event listeners for you, right? When you are done with the Vue model, if you destroy it, Vue removes the listeners, so there's no memory leaks. And also, you can use very simple expressions in there. So the way you do it is v-on click. So this is a directive, and this colon in the directive syntax stands for an argument. So we're using the v-on directive with the click argument. And we can bind it to something in in the Vue model. So we're binding to a method called toggle. So now we need to define this method. So to define methods in your Vue instance, we will use the methods option. Okay, so we just define the toggle method. And what it does is actually we need to toggle this specific to-do. So we will receive the to-do here as an argument. And what we do is just to-do.done equals not done. OK, so I think that should work. Wow, this button looks terrible. But it works. All right. So we have completed this full cycle of mapping our state to some rendered DOM, and then we are receiving user input events, and in turn we are mutating our state again, which triggers Vue updates again. So we completed this full update cycle. And what I want to do next is, actually, I've kind of having a blank. OK, I want to introduce the shorthand for these event listeners. So because you will use von a lot, we have a special shorthand syntax for it, which is using the @ symbol. So let me load this as a Vue component. All right, so if you're using the Vue component syntax highlight, you can open HTML files with it, and you'll get expression highlights inside your Vue templates. So now it's easier to see that this is a directive, this is a directive, and things inside them are expressions. And so this should still work the same way. Great. So now, how about adding new stuff to the app? All right. So what we can do is adding an input box. So type text. And what we want to do is when people type, actually, why don't we use a form? So when people type in this box and hit enter, we want to, actually, button type submit, add to do. So we want to add this content of this input box as a new to do. So there are several ways to do this, right? If you're using jQuery, what you will probably do is you will listen to the submit event of the form. You'll somehow give this input an ID or a class or whatever. You would then try to locate this input element, retrieve its value, and then send it, do something with it. But with Vue, another way to do this with Vue is we can use the Vue model directive, which what it does is keeping the value, the DOM value of this input box in sync with a piece of data in your model. So we need to declare a new field in our data called new to do, and it's a string, and it starts with an empty string, and we bind it to the Vue model directive of this input box. We can actually ignore this. So now what this achieves is whenever you type in this input box, the new to do value will be updated. So to show you that actually works, we can just render the new to do in the view to see that it is actually updating, right? So this is two-way data binding. We are directly receiving updates inside the DOM and keeping this in sync. So why is this two-way? Because if you go into the console, make it really big, we have our VM, right? We can directly change VM values. New to do equals hello, and it updates the input box as well. So this is two-way binding. Now, because we know that the new to do will always reflect the actual value of the input box. We don't need to worry about locating this element and retrieving its value anymore. We just use new to do it as our source of truth. Now, so what do we do when we submit the form? We can add a submit event handler to this form, right? So add submit equals add to do. And again, we need to define this add to do method. So here we have a problem, right? This submit event, when you submit a form, the default action of the browser is to reload the page, right? So we know that we need to do event.prevent default on the submit event in order to prevent the page reload. So you can't do it in the add to do method because it'll, by default, if you directly bind to a method, it'll receive the native DOM event as the first argument. So you can do event prevent default here. But that's kind of tedious if you want to do a lot of them, right? So Vue provides a concept called modifiers in directives. So modifiers are things that's denoted by a dot in these attribute names. So what it does is apply additional special behavior on these directives. And the v-on directive, these event listeners have a lot of modifiers, and one of them is prevent. What it does is simply call prevent default for you. Right? We also have like stop, which is calling stop propagation. So, or you can use key codes for on key events, which are pretty convenient. So submit prevent equals add to do. So when submit event happens, call prevent default, then trigger the add to do event. So here we have, what we can do is actually just pass new to do here, right? So we can add to do, new to do. So new to do. So this dot to do's dot push text new to do done false. Okay. Yay, worked. So I guess by now, even if you've never used Vue.js before, you can somehow tell the thing we're doing, we didn't even touch the DOM at all in this whole process. We never did a single line of direct DOM manipulation. All we did was writing templates that's declaratively mapping what you want to do to the actual DOM. And the actual imperative parts that we're doing is just manipulating state, right? We are just, setting a JavaScript property. We are just pushing into a JavaScript array, right? These things you already know how to do, and it's really easy to understand. So there's no more messing around with jQuery selectors and trying to, create a new LI element and insert into the correct container, or, handle the form event and then, add the correct thing into the place. We got rid of all that. And what we are concerned about is our template and our state. So this is what Vue.js is really about, and I hope this quick demo gives you, even if you've used it before, I hope this gave you a better idea of how it works. So, okay, so back to our presentation. So the demo just now demonstrated how we are handling directly mapping a piece of state which is already, a concrete piece of state. It's in memory, it's there. You can directly manipulate it. You can persist it by, sending it in a post request to the server and all that. But other times there might be a concept called derived state. So derived state is, for example, when you want to do list filtering, right? For example, in our to-do list app just now, what if I only want to display to-dos that are done or to-dos that are not done, right? Because our source of truth is just this whole list, right? The whole collection contains all to-dos, whether it's done or not done. So this is similar to how you would do a query to your database, right? Because your database, the to-dos collection contains everything, right? It doesn't have like, ready-to-use collections of like done to-dos or not done to-dos. What you do is you query it at runtime. You would query, say, give me all the to-dos that are done. Give me all the to-dos that are not done. But you're not saving these anyway, right? These are derived state. They are temporary, used for displaying to the user only. But we don't want to create copies. We don't want to maintain copies of these state. We want, for example, one way to do it is you can say, I have 3 arrays. One array is all to-dos, the other is done to-dos, the other is not done to-dos. Now you are asking for trouble because you have to maintain the correctness of these 3 collections. Whenever a to-do is toggled, you need to remove it or push it into the correct array. And we don't want to do that. We want the done arrays and not done arrays to be totally automatic. They should be reactive too. So they are derived state, and this is what computed properties are for. So computed properties in a Vue application is created by declaring computed option block in your Vue instance. Let me just divide this so it's clearer to see. So now let's say we want to display done to-dos only. Actually, not done to-dos only. So not done to-dos. I'm just bad at naming things, but don't judge me for that. So a computed property is a function. So this is a very declarative function, which you are just returning things from it. And what you do, because it's derived state, right? You're returning some derived state based on the concrete state. So return this dot to-dos dot filter, right? To do done, not done. So this is a ES6 arrow function syntax. So what this does is filters through our to-dos and only return an array containing those that are not done. And this creates a copy of this to-do. So the magical part about this is we are iterating through this while we are computing this. And Vue will keep track of the dependencies of this computed property. So it knows it depends on to-dos. It knows it depends on the done property of every to-do inside the collection. So whenever you change something in the to-dos collection, this thing will run again. And it will return the latest correct copy of the not done to-dos. So let's see if that is actually the case. Instead of to-dos, well, actually, we need another collection. So let's do v4 equals to-do in not done to-dos. To-do text. OK, so let's just add something so that we can see that it's different. As you can see, we have delivered talk, which is not done. If we toggle it, it's gone. So here we have managed to create a piece of derived state that is totally reactive, declarative, dependent on the actual source of truth. You don't have to worry about maintaining the correctness of this separate collection. It'll just be always correct because it's derived state. So similarly, we can create another computed property that returns to-dos that are already done. So this is basically a pretty decent to-do application now, I would say. So we will add some CSS styling to it, and this is what we will end up with. Well, I lied. This is the official to-do MVC implementation using Vue 2.0. So as you can see, we have a lot of complex operations. For example, you can toggle all of them, toggle one of them. You can edit them. You can edit and cancel the edit. You can clear everything. And if you add stuff, and you can toggle between filters. So this is filtering. This is using a computed property list that displays only the completed ones. And as you can see, it remains correct even if you are toggling them dynamically. So, OK, That's the part for dynamic derived state. Okay, so the next thing we want to ask is, how does it work really? Like, how many of you think you actually understand how the reactivity works in Vue.js? So I don't think I've seen a single hand, but I won't blame you if you raise your hand. Like, there is a chapter in the guide that explains this, but in most cases, you probably don't really need to understand how it works. Like, you just need to understand there are some edge cases. But the real way we do it is using the ES5 object-defined property method. What it does is it essentially makes property access a getter. So when you access a property, it will call the getter function. And when you set the property, it will call the setter function. All right, pretty straightforward. But with this in place, it gives us the opportunity to do all this reactive magic. So when you first create a Vue instance, Vue will convert the data object to become reactive. It does so by recursively walking the object and converting every property into getters and setters. And inside those getters and setters, the work we do is the setter obviously will trigger change, and the getter registers dependencies. And it only registers dependencies when we are explicitly collecting dependencies. That is, when we are rendering or when we are computing a computed property. That's when we will explicitly let the system know, hey, we need to keep track of what dependencies are being touched during this process. And when the process finishes, we have a list of dependencies that was used during that, whatever, be it rendering or be it computed property. So now we know that, for example, this rendering, this directive, depends on these dependencies. And when those dependencies corresponding setter is triggered, we will notify that directive, say, hey, some of your dependencies changed, and it will then do the corresponding work of updating the DOM. So this is how it works. This is our object, and so this is actual DOM, right? So we have some mechanism, the rendering layer that updates the DOM. So in 1.x, we use directives as a relatively catch-all term for all the text bindings or VLs. In 1.x, they are all directives. In 2.0, they are abstracted into the virtual DOM layer. But the reactive system is exactly the same in 1.0 and 2.0. What they both does is we have a concept called watcher, which is responsible for collecting these dependencies during a collection cycle. So once a collection cycle finishes, this watcher is what is responsible for notifying the actual rendering layer that things have changed. So when you trigger the setter, it notifies the watcher in turn notifies the rendering layer, which eventually updates the DOM. So as you might have known, because we rely on getters and setters, if a property is not present when the object was observed, it will not be reactive. This is why Vue.js does not support adding new properties directly to your model objects. So this is maybe an annoying limitation in some cases, while obviously there is an API that allows you to do that. But I actually think it's good because it demands you to explicitly declare all the fields in your model state. So think about it as declaring the schema for your database, right? You wouldn't create a database without a schema, because then you wouldn't even know what is in there. So when another dev look at your database, they'll be like, wait, this field is here, this field is not here, right? It's going to be a mess. So similar in the front end, right? Think about your client-side state as data. Because they're data, you want them to be predictable. You want them to be deterministic and consistent, right? So it's a good idea to explicitly declare the fields, the reactive fields in your client-side state, right? Even if they don't have an initial value, you can just declare it as null or an empty string or things like that. But at least when you look at your code, you will see, hey, there's a property here. I can use it in the templates, and you don't have to. So imagine if you are able to arbitrarily add new fields whenever you want. A possible situation is you look at a piece of template and you see, hey, it's using this property here. Let me look at the data code, and it's not there. When did you add it? You don't know, right? This leads to a lot of problems. So it's actually a good habit to explicitly declare the reactive fields in your client-side state. OK, so we're done with reactivity. You want to take a short break? I can use some water. All right. How much time do I have? OK, now we are getting into the second part, that is components. Right? So the idea about components is I think it's almost, it has almost become sort of like a common sense, or almost all major front-end frameworks have agreed upon the component model. If you think about React Polymer, it's really tied to custom elements. But React Polymer, Angular 2, Ember, and Vue.js have all settled on almost the same component model. And the premise is that most app UIs can be broken down into components, right? Essentially, they're just nested boxes. That's what UI is. Right, so nested boxes can be looked of as nested components, right? Each piece of content in your UI corresponds to a component. And these component forms a component tree. So this is kind of parallel to the actual DOM tree, but the DOM tree is a mess. We don't want to think about it. Component tree is much more reasonable, right? It's actually even more semantic than HTML, because instead of thinking about divs and spans and A's and P's, you are thinking about the actual components, like the header component, the sidebar component, the main content component, the comment component, right? This makes much more sense. So and another benefit is by dividing a bigger piece of UI into smaller components, we're doing divide and conquer. We are dividing them into maintainable little pieces. We are dividing the complexity into more manageable bits. So when you look at a single component, it's easier to reason about. What we need to do is define a clean contract of how components could interact and be composed. If we can do that, we have the mechanism for first creating self-contained, maintainable little pieces that are maybe reusable. Then we can put them together just like toy blocks and to compose a bigger application. So basic syntax of registering a global component in Vue.js, you do view.component and give it an options object. This is essentially what you would use inside a new view call, right? One of the gotchas is the data option. I'm sorry. The data option, instead of directly giving it an object, you need to give it a function. The reason is that, actually, let me do this in code. It might be easier. So again, we are going to work on top of our to-dos application. We want to extract our to-do into a component. So let's do that, okay? As we demoed just now, we can register a component. with this. So to do is the name of the component. This is also how you would use it in your parent component template. So once you register to do, you can use it in templates like this, just like a custom element. So what this to do does is it'll accept a to-do's prop. It actually doesn't have its own private state, so unfortunately. So we can declare 2 props. We can actually just declare a 1 prop, which is to do, right? A to do component is responsible for displaying a to do. So the props is the mechanism that allows a component to receive external data, right? Because it does not really want to concern itself about where this data comes from. Think about props like arguments of functions, right? A function will receive arguments and doesn't care where the arguments come from, right? That's the responsibility of the outer function that calls this inner function. Similarly, a component, when it does not want to concern about where a piece of data comes from, you declare it as a prop and expect whatever parent component that is using this as a child component to feed the data into it. I have a diagram here that kind of shows what this is. So data passing with props, you can pass data using this syntax, which we'll talk about. So let's declare the template first. So the template is essentially this, right? So I'm just going to use ES6 template strings here. So in 2.0, every component must have a single root node. So this to-do component actually expands to an LI. That is what it does. So now we have this reusable to-do component. We can just, we no longer use the LI here because that will be replaced by the to-do itself, right? So we are iterating over our to-dos and just rendering the to-do component. But hey, remember we need to pass the to-do that's being iterated on into the component so that it can display it. So the way you pass props is using the vbind directive. And I forgot to mention that vbind is the directive that you use to bind like attributes or things like that. So if you do like vbind id equals something, you can like dynamically bind the id attribute to a value in your model. And vbind, similar to von, also has a shorthand, which is just this. So you can do like something like this, which will dynamically bind the ID attribute of this div to the dynamic ID property in your Vue instance. But we use this exact same syntax for binding props of components. So what we can do is just sending to do. So when we're using v4 on this, everything else on the same element actually has access to the current iterated scope. So this to-do prop has access to the to-do that's being iterated. So think of it as the alternative syntax of doing this is you can use a template v4, right? This becomes more explicit, right? Because this to-do component is actually inside this iteration scope. But our shorthand is you can get rid of the v4 and just use v4, get rid of the template and just directly use v4 on the to-do itself. But everything else on the same element actually will be having access to this, okay? So we are now iterating over the to-do component, to-do list. For each to-do in our to-dos, we are rendering a to-do component and passing the to-do as a to-do prop. Oh, we have too many to-dos. But I hope that works. Let's see if it does. Hooray, we have exactly the same, right, toggle says, right, because now toggle is actually right? Toggle is now used inside this child component, and the child component does not have access to the parent scope, right? Each component has its own isolated scope. So in the very early versions of Vue.js, child components implicitly has access to parent scope. And looking back now, I think that was a terrible idea. Some people actually liked it, but imagine that that's the case, and you are being able to implicitly use the parent method toggle inside your child component. And later on, you divide these components. They grow bigger and bigger. You divide them into separate files. And another dev comes in and look at the to-do component and see, hey, it uses this toggle method here. Where is it defined? I cannot even find it in this to-do component. Now you are just out of pure luck. You have to look at every possible case where this to-do component is used to find out where this toggle method is defined, right? That is just terrible. So limiting the components template to its own scope makes sure that everything that's used in the component is defined in the component itself, so that the component is, in fact, self-contained. So it can be portable, it can be maintainable, it becomes maintainable. So we need to move this toggle method into the to-do component itself. But it does the same thing, right? It still just sets the state. And let's see if that works now. Yep, again, so it works as before. And now we have this to-do component, which is self-contained and reusable. That's the most important part, right? Because remember how we have another list that are the not done to-dos. And previously, we were just simply displaying its text. But in fact, we can just reuse this, right? So exact same thing. Right? Now we have this toggle functionality even inside the not done list. So everything just, works, I think. Cool. So instead of duplicating the same piece of functionality, the same markup, the same event bindings in two places of your template, you can just reuse the same component. And if this component grows more complex in the future, the parent component doesn't need to change a thing, because that's the concern of the child component. We now have decoupled the parent component and the child component. The only way they interact with each other is by passing this to-do object through the prop. So that's the interface, right? Another way of handling the toggle is we might want to reduce the responsibility of the child component to make it more portable. For example, we don't actually want the child component to be touching the to-do, to be mutating it. Instead, what we can do is just emitting an event to the parent, right? So what we can do is bind it to toggle, and when it's toggled, this emit toggle, right? The even simpler way of doing it is just doing an inline emit. You can even get rid of that. So we're using the component event interface. This is an instance, Vue instance method called emit that emits a custom event on this component instance. And how do we react to it? Well, similar to VR, you can listen to it in your parent template. So toggle equals toggle to do. We are reacting to this child event that is being emitted and calling a method in the parent scope. Notice that the child component has very, very simple responsibility. It simply displays stuff and emits an event when the user does something. But what side effects this will actually cause, it doesn't know, and it doesn't care about. That's the responsibility of the parent component. So now this child component is very pure. It doesn't even mutate anything. All the data mutating logic is now contained in your main app. So again, we can define the same method. We're moving it back into the main component, and that is exact the same logic. To do done equals not to do done. Okay. So when we have a lot of things, we can break them into multiple lines so that our template looks nicer. So exact same functionality, but so these are different kind of trade-offs, right? We are, again, making our main template a tiny bit more verbose, but we get a much easier, simpler child component that's much more portable, because you can use this same component in another context, and you might want to do something different when the toggle event is emitted, right? This opens up more possibilities of how this to-do component can be reused. And we are, again, centralizing all state management logic in our parent app, which is also a good thing, because you want, it's a good idea to be able to see all things that might change your state at the same place. This is what I would call the recommended interface for components is you take data in via props, you cause side effects in the parent scope by emitting events. So it's like data in, events out. And this way, you can create components that are very thin and very more reusable components, I would say. Because this way you are essentially you will essentially be able to, as I said, centralize your state management logic in the same layer, in the layer where you use all these child components, instead of scattering these state management logic into multiple components. Because state, although we've made state management simpler with Vue.js, it can still get complex if your state itself is complex, right? So state maintainability is still something you definitely want to be concerned with. So scattering all the places that might mutate your state across a lot of different places is bad. Being able to centralize them in the same place so that you can reason about what could potentially change your application state is good. And using this data down, events up, I would say interface or the style of using components, you would naturally end up with more centralized state management logic, which is what I would recommend. But this might be, but this is also situational, because if your components are simple enough, then the benefits of doing this may not be that obvious. But as seen in this demo, but I hope I've made the point about making your state more manageable and maintainable. Okay, so we're done with the component and props. Now I want to talk about virtual DOM in 2.0. I think a lot of people asked the question about virtual DOM in 2.0, and why did you decide to switch to virtual DOM, and what does it actually mean? Like, what makes the difference? Because so far, as you might have noticed, everything we are using here is exactly the same with 1.0. Did you notice that? So if you stick to the most basic parts of how Vue.js works, upgrading from 1.x to 2.0 will be a breeze. But there are some new things brought about because of virtual DOM. We have some new concepts that are optional, but is helpful to know if you want to understand how it works. So first, to understand what a virtual DOM is, we will need to talk about the concept of virtual DOM tree. So we know we have a real DOM tree somewhere in our HTML page, but what is a virtual DOM tree? A virtual DOM tree is just a JavaScript object tree that somehow represents what the DOM should look like. So this is just a div, just a plain JavaScript object. It has a property called tag, which is div, and it has an array called children, and the children is in turn more virtual DOM nodes. We call these V nodes, right? So every V node simply contains some information about what DOM node it represents. It can contain the tag name, its children, and its text. And that's it. Also, text nodes are represented as virtual DOM nodes too. So very simple, right? So when you have a tree of these virtual nodes, you have a representation of what the DOM should look like. But this is much, much lighter weight than the actual DOM. So if we were to create two versions, one is the virtual DOM tree of this structure, and we create a real DOM tree of this structure, you'll realize that the virtual DOM tree, you will see that the virtual DOM tree is probably hundreds of times less memory and cost in terms of creation. So this is why virtual DOM tree makes it possible to do what we talked about, that is re-render the whole thing whenever anything changes, right? Because it's cheap enough to do that, right? Obviously, it's not going to be actually that cheap if your application is like thousands of components, but we'll talk about how we optimize that later. So for now, let's just assume we represent our whole application DOM state using a virtual DOM tree. Now, how do we create this virtual DOM tree, right? Obviously, we don't want to create it by hand, but before we go into that, so for initial render, what we do is we will have something called a patcher. What the patcher does is it will take a virtual DOM tree and create the actual corresponding real DOM tree. That's for the initial render, right? So when you first render the page, we will first render the virtual DOM tree. Then based on that tree, we'll create the real DOM tree. So this is actually very, very efficient compared to how Vue 1.x does things. So it is a bit complicated to explain, but in 1.0, we do all these v-ifs and v-fors using virtual fragments. And when we do these virtual fragments, we need to do like caching of the template and partial compilers and that stuff, which actually becomes quite expensive. But with the virtual DOM in 2.0, the initial rendering performance has increased drastically. As a reference point, if you render, say, a table of like 10 by 1,000 rows, you would see like 4 to 5 times increase in performance for the initial render, which is just, a big difference. So, and the next thing, so what happens when some data has changed, right? We want to update the DOM now. So instead of directly mutating the old tree, we just create a new tree. So the old tree is still there. We create a new tree that represents the next state that the DOM should be in. And the patcher will take both trees and compare them. We call it a diff and patch process. So we will find out what has changed in this new tree and apply the minimal amount of DOM manipulations to the actual DOM tree to make sure it accurately reflects what the new tree looks like. So this is called a patch process. So this is what happens when when something changes in your app. So how do we create these trees? Render functions, right? So a render function in 2.0 is just a function that returns a virtual DOM tree, right? So this is what actually Vue uses internally to create virtual DOM trees. And you can manually write these functions too. And we'll see how it looks like. But before that, how do we create render functions? So this is what the 2.0 compiler does. The compiler takes care of translating the template into the render function. So some of you might have noticed that the 2.0 comes with two parts. One is the two different builds. One is the standalone build, and one is the runtime-only build. The difference between the two builds is whether it includes this compiler or not. Right? So the runtime-only expects directly working with render functions. So it can become lighter because it doesn't have to compile anything. The standalone build needs to include the parts that takes care of translating string templates into render functions. But it's not that much heavier. It's like, I think the compiler itself is like 67K gzipped. So the size difference is not that much. The runtime only build is 15K gzipped, and the full build is 21. So there's not too much overhead if you want to use a standalone build. But if you want to squeeze that extra little size, you can use the runtime only build. But this is what the compilation actually looks like, right? So we have this template. This is string template. And what the compiler does is just translate into a function that looks like this. It's a render function, and this create element method is what we use. It wraps some like logic of creating virtual DOM nodes for you. And the syntax is you pass in the tag of the element and additional data. Some data, for example, if it has attributes, you can pass attrs, id demo, corresponds to this. And then the third argument is an array of its children. And here again, we are creating h1, and the shorthand is if you don't have any data, you can omit the second argument, directly pass the children as the second argument, and if the children is just a single string, you can just directly pass that string. So here, we have translated this into the JavaScript equivalent. Obviously, the compiler-generated code will be a bit more compact, a bit harder to read. This is how you would write it manually. So the full picture of the initial render is we have a template, compile it into a render function. And on the initial render, we will use that render function to generate our initial virtual DOM tree. And when we are calling that function, we have a watcher that is watching it. Right? Remember the watcher that we talked about in the reactivity session? So when you are calling the render function and generating the virtual DOM tree, the watcher is also collecting dependencies. It knows what dependencies this render function depends on. So once we have the initial virtual DOM tree, we generate the actual DOM tree using the patcher. So this is how the initial rendering works. And the next step when something happens is triggered by watcher. Because, like, for example, a user handler changes some data, triggers the watcher. The watcher triggers the re-render. So the watcher knows which render function depends on that piece of data. So it triggers the corresponding render function to re-render, which generates a new virtual DOM tree. I forgot to make this big. We have the new virtual DOM tree, and we still have the old virtual DOM tree, right? Diff and patch, and voila, we have applied the minimal amount of DOM manipulations to the existing DOM without blowing it away, and still the same reactivity system that we are accustomed to in 1.0. Like, this all actually happens under the hood. You don't even need to care about how they work, but I think it's helpful if you understand how it works. So, and so one possibility in 2.0 is that we have now as a user, you can still keep using templates. They still work exactly the same way. But you also have the opportunity to drop one level down directly to the render function level. And why do we want to do that, right? Because it seems much harder to write than templates. So the answer is that render functions give you more flexibility than templates. Because when you're using templates, you're limited to the built-in syntax, the constructs that the Vue template syntax gives you. You only have v-if, v4. Like, what if you want v-switch, or you want like v-whatever? Right? So if you think about it, when we are compiling v-if into a render function, it actually is compiled into a JavaScript ternary expression, which is really simple. And the v4 is compiled into a JavaScript map call. So we take the array that v4 is supposed to iterate on and map it to an array of DOM nodes based on each item in the collection. So as you can see, like each construct in the template syntax has a corresponding JavaScript representation of it. But the JavaScript syntax, it's far more although it might be harder to write than templates, it is far more powerful, right? It is a Turing-complete language. So essentially, render function gives you this superset of what templates can do at the cost of being slightly harder to write. But there are certain scenarios where using a render function might make sense. And I can give you an example. For example, let's create a new file. So now instead of using the direct DOM as a template or using an inline template option, we are going to use the render function. All right. So the render function receives the create element method as the first argument. So this is kind of long to type, right? So a very conventional way to shorthand it is using H, which is like the H in HTML5. So because HTML is hypertext. In other virtual DOM libraries, this style of creating virtual DOM nodes is called hyperscript. And taking the first letter, this is where the H shorthand comes from. So you will probably see this a lot in a lot of examples. So what we want to do is just return nodes, right? So the simplest way is, so remember the return nodes will replace the node that you're mounting to. So you want to keep the same ID if you do that. So you can do this. Now we'll give it a list of children. So let's do span, maybe. Hello. So let's see if that works. Hello. And let's confirm that it is indeed rendering a span with hello. So now I think you kind of understand how the render function is supposed to work, but under what situation. So I want to also give you a more example of understanding how reactivity plays into it. So let's say we have a data property called OK. You have access to that inside render function as this.OK. So if you want to conditionally display different text here, you can do this.OK, hello, bye. All right? So now when we mutate the thing, vm.ok equals false. Oh, that's not it. We didn't assign it. Okay. So we are achieving almost exactly the same thing with the equivalent of template, but we are using pure JavaScript. And you can even do more complex things. For example, you can do like const message equals, maybe you can do like switch this.ok. If OK might have multiple values, like 1. So you can do like case 1, like let message, and case 1, message equals 1, right? And like case 2, message equals 2. So this is relatively hard to do in templates. Well, you can obviously do it with a computed property if you stick to templates, but with render functions, you don't even need computed properties. You can just use the power of JavaScript to do these things that the template syntax doesn't actually naturally support. And even more important thing that you can do with render functions is that you can programmatically do things with the children, the slots. So for those of you who don't know, components, when you use a custom component, right, you can nest things inside of it, right? So because components have their own templates, where do these things go, right? these things are called, in Angular, there's a concept called transclusion. But in Vue.js, we call these like slot content. So these content are somehow compiled in the parent scope, because this is where they are declared, written in the template. So they're compiled in the template scope and sent down into the component as slots. So what the component can do is using the slot API to compose these inserted content within its own template. Let's create the test component. And we are just going to completely remove that. So if you're using templates, you can do things like slot. So what it does, this slot means take whatever is inside of main and display it here. All right, so as you can see, this div hello is being inserted into the child component and displayed at where the slot is. To make it more obvious, we can add a header here. So you can see it is indeed displayed in the child's component, but it is declared and compiled in the parent. So this is a very useful mechanism, especially when you're building composable, reusable components. For example, you can build, say, a model component that receives the content to display via slots. So the way you would use it, for example, is something like this. And like slot equals main content. And if we rename this to model, and we can do like slot name equals main content. So this will take this piece of parent content, insert it in that right place. Imagine you can also do like div slot equals header, or div slot equals footer. So this gives you a way to, using these slots inside child component to compose them at different positions in the child template. But there are cases where the slot syntax doesn't really, fully suffice what you want to do. For example, if you want to do a like array of inserted content, or you want to dynamically display slots, or there are, I can't give you a very simple example because those use cases usually arise only in complex applications. But when you run into those situations, you will find that sometimes you feel limited by the template syntax because you don't have the full power of a Turing-complete language to do what you want. So that is the time when the render function could come in. So what you can do, the equivalent of doing this in a render function is render return hdiv h2 child and h. So we don't use h here because we have access to something called this.slots. So const slots equals this.slots. So this.slots is an object that contains the mapping of slot name to slot content. If it doesn't have a name, it's slots.default. Here, because we have a name, so content equals this slot's main content. And we just give it here. Whoops. Unexpected identifier. On line 15. Oops. Yeah. Okay. Here we go. So we have the same functionality as before, but we're now doing it programmatically. And now because you are doing everything in JavaScript, you can do anything to this. You can even modify it. All right. So an example is So I'm just doing a very hacky example here. This is probably not what you want to do in a real application, just to show you that you actually have the ability to mutate these transcluded child, because content, if content, because it might be empty. So content is actually an array. You can nest arrays in the child array. So we can do like content.forEach node, if node.tag, so that we know it's an element. Node dot, so let's give it an ID. Right, so we can change its ID. We can do node.data.attrs ID equals changed. Whoops, something went wrong. Cannot set property ID of undefined. It's static ATTRs. Okay. So the drawback of using render functions is that you have to somehow familiarize yourself with the vnode syntax and what properties may have in its data objects. But once you get past that, there's another good thing is when you have some render functions, you can directly inspect that error, inside the console using breakpoints, using full power of JavaScript debugging capabilities to see what's going on. And static ATTRs. So if we go into the elements, and to confirm the ID is indeed changed. So this is something it's just impossible to do with template syntax slots, right? But we can do it in JavaScript if you use the render function. So this is just one of the examples of how JavaScript gives you the full control of what you actually want to display. But there are many more cases that might prove useful. And to give you some ideas, for example, the new transition API and the new Vue Router 2.0 router view component, they're all using render functions because they implement some really complex functionalities that can be really limiting to express using templates. But with render functions, we are able to, it becomes much more straightforward to implement. So on a general note, render functions are best suited for situations where the component is somewhat like structural or really components that implement non-trivial, unusual functionalities, I would say. Sometimes the components can even be used in a very, not used to display stuff, but used to decorate, alter, modify content, or enhance stuff. So for example, the new transition API in 2.0 now uses components instead. So that's an example of how the transition component is actually used to modify and enhance the wrapped children inside of it, which we'll somewhat get into. I think I should probably talk about the new transition API a little bit because that's also one of the parts that changed a lot in 2.0. So let's open a new one. So let's say I have a div that is toggled by OK, hello, and const vm data, OK, true, amount app. So we will have a button that toggles it. So it just toggles the visibility of the thing. So now we want to apply a transition to it. So previously in 1.0, what you would do is just add the transition attribute. But in 2.0, what you want to do is use a transition component to wrap it. With this, we are back to the same familiar thing. So obviously, we need to give it a fade, maybe. Transition, opacity, And so this is a default transition. It doesn't have a name, so we'll still use the V prefix, or you can give it a name, fade. So, so we can use like fade, enter, opacity 0. And a change is that when you use fade leave, previously you would do this. Now you need to do this because fade enter and fade leave indicates the starting state of a transition, and fade enter active and fade leave active indicates the end position, because the class will remain on the element during the transition and then removed at the end. So for a fade transition, what we want is when the element enters, it should start at opacity 0 and animate to full opacity. And when it leaves, it should start at full opacity and then animate to 0. So that's why these two are different. So I think, yes. So it works. Very simple transition. Almost, so in terms of CSS, it's almost exactly the same as before. Difference is the syntax that you need to wrap things inside transitions. And a good thing to note, a cool trick that I want to show is that what you can do is give two elements. Right? So we want to animate between these normal elements. They're not components. Note that the normal transition component can only have one children at a time. We are able to do this because we are using VIF and VLs, so that we know that there will always be only one element present. So, but the thing is, one gotcha here is that the virtual DOM will think that these two divs are exactly the same thing because they look exactly the same, right? So it will think, oh, it's just the same element. I wouldn't do any animation at all. So how can we tell that the virtual DOM, hey, these are actually two different things? We can use this new key property, which is, this also replaced the track by on v4, in case you didn't know. But we can use it on normal elements here to give it a different key, so that the transition wrapper knows that they are actually different things. Well, like, you know, the virtual DOM checks the equality of these components by looking at the element itself only, because the children are considered one level down. So the content inside of it doesn't matter. It's important that you know that these two divs will actually be looked at as the same thing. So now we got transition between these two normal elements. And what's more, we support transition modes on these normal transitions too. So very simple stuff. You can achieve these complex animations. There are a lot of gotchas in this if you were to implement this manually. But with Vue, you can do it declaratively using the new API. OK, I think that's all I've got for now. I think I've got 5 minutes left. I can take a few questions, if there are any. Thank you. No questions? OK. Do you need a mic?
How well does this work with jQuery plugins and such?
Slideshow plugins. So it depends on how you build it. So in most cases, jQuery plugins will do arbitrary DOM manipulations to the things inside of it. So for example, if you were to use, like a sortable or draggable plugin, it will probably have some problems. But if you're using, say, like a slideshow, what you can do is write a custom component that only renders a single div. and so that the virtual DOM will think that it's just a div. Then you can initialize the jQuery plugin inside that div. So the virtual DOM will basically skip anything inside because it doesn't care about it anymore. So the jQuery plugin can do whatever it wants inside of it, and you can use the same functionality as a normal Vue component elsewhere of your application. Does that make sense? Yeah. All right. Yes.
So you were mentioning the difference between the runtime only build and the full build. Does the runtime only build imply that you put your source code through a compilation step that is going to actively convert your templates into?
Exactly. So the compilation step, if you are using Vueify, Vueify does that for you, right? So if you're using Browserify with npm install versions of Vue, when you require Vue, the default version is the runtime only version, because it assumes that you are using Vueify or Vue loader or some compilation step. So when you require a Vue file, the template will already be compiled as render functions. So there's no overhead at runtime to do extra compilation. You don't have to ship the compiler to the browser at all. But if you want to use templates somewhere in your application, not processed by a compilation step, then you probably still need to use the full build. Okay. Anyone else? Who was first? Okay, there. Back row.
Say you're rendering about 50 different components on in DOM. Would it be more efficient to just say they all have the same method? Would it be more efficient to actually just use emit on your parent application? Would that actually decrease the load? Or?
Sorry, could you repeat the question?
Sure. So say you had about 50 different components that you're rendering in the DOM, right? And they all have the same exact methods. Would it be more wise to use emit on the parent, like the actual parent Vue instance to decrease load? Would that decrease the actual load time?
I'm not sure if I understand the question, but the internal event system is really, really lightweight. Like in most cases, you probably don't need to even care about it perf-wise. In 2.0, the only thing that you might want to consider in terms of perf is the number. Actually, there is very little that you need to worry about in terms of performance in 2.0 because because the interesting part is the initial render is blazing fast, and consequent updates compared to something like React, because in 2.0 each component gets assigned a watcher, right? So essentially every component's render function becomes a reactive boundary to track the dependencies. So let's say you have like 1,000 components on the page, and some data changed. It triggered maybe 5 components need to re-render. So Vue automatically knows that that's these 5 components that need to re-render because they are keeping track of their dependencies. Unlike in a more coarse reactivity-based system, like other virtual DOM libraries, the typical strategy is re-render every component, but selectively implement these like short circuit checks at certain parts of the subtree. But like this is essentially a optimize only when you find a slow strategy in comparison to Vue 2.0's optimized by default strategy, which I think is just, you don't need to think about it even. But I'm not sure if that's directly related to your question, but the point I want to make is how you use events is probably not anything significant in terms of performance. Yep. Yep.
Can you discuss real quick the server-side rendering?
Oh, sure, yeah. So in 2.0 server-side rendering, so one of the reasons we switched to virtual DOM is because virtual DOM enables server-side rendering, because we have an in-memory representation of the eventual DOM that we want to render. So instead of rendering to the actual DOM, we just render them to strings. The way you use it could be hard to explain in a few minutes, but my suggestion is if you go to GitHub, I don't have internet. Oh, okay. But if you go to GitHub, the Vue.js repo, go to the next branch, and go into Packages, Vue Server Renderer. Its README has pretty comprehensive documentation on how to use server-side rendering with 2.0. So it has documentation, but the thing is, using server-side rendering from just using the basic API to actually building a fully universal application that allows you to pre-render properly on the server and hydrate properly on the client is actually involves a bit more moving pieces. The best thing right now to look at is the Vue SSR demo repo that's under my account, I believe. That's YYX99003/Vue SSR demo. That's the one you currently want to look at. But in the future, we will be providing a more comprehensive example of using, including using Vue Router, Vux, and Vue 2.0 together with fully, universal rendering on the server on the client. And in the future, we might be able to provide a standalone Node.js service that just takes in your application bundled JavaScript and it takes requests and return the result so that it can be, it's a Node.js process. You start the process as a service, so you can, run your Laravel application in one place and just send requests to the server-side rendering service to get the stream back. So that's something we are planning to do, but it's not there yet. Okay. So I think we're past time, so thanks everyone for coming.